Welcome to Astronomy Daily, your source for the latest news from across the cosmos. I'm Avery.
And I'm Anna. It's great to be with you. Today, Avery, we're talking about everything from the first wheelchair user heading to space to a star system that's getting ready to put on a celestial fireworks show.
Absolutely. We'll also be diving into a new survey of our galactic neighbors, a surprising discovery about the sun, the new race to mine the moon, and the incredible tech being built to study the planet right next door. Let's get started. First up, a truly historic mission from Blue Origin. They're targeting December 18th for their NS-37 mission, and it's a huge step forward for accessibility in space.
It really is. On board the New Shepard vehicle will be Michaela Benthouse, an aerospace engineer at the European Space Agency, who is set to become the first wheelchair user to fly to space.
That's just fantastic. And she's not just a passenger, she's an aerospace engineer herself. That adds another layer to this.
Exactly. It's not just about tourism. It's about opening up the field of space exploration to talented professionals who might have been excluded in the past. It's a suborbital flight lasting about 10 minutes, but it sends a powerful message that space is for everyone.
It really challenges the old right stuff astronaut mold. And she'll be joined by a pretty interesting crew, including investors and even a former top engineer from SpaceX, Hans Koenigsmann. And it's not just a symbolic gesture. The engineering that goes into making a spacecraft accessible for someone with different physical needs is non-trivial. It forces designers to rethink everything from seating and restraints to how crew members interact with the cabin in microgravity. These are solutions that could benefit all future astronauts.
A diverse group for a landmark flight. We wish the entire NS-37 crew a safe and incredible journey. All right, let's shift our focus from low Earth orbit to our nearest galactic neighbors, the Magellanic Clouds. A major new survey is about to give us an unprecedented look at these satellite galaxies.
Ah yes, the large and small Magellanic Clouds. For listeners in the northern hemisphere, they might not be familiar, but they're a stunning sight from southern latitudes. So what's this new survey, the 1001 MC, all about?
The key is the technology. It's a 5-year survey using the foremost instrument on the Vista telescope in Chile. Now, past surveys have given us beautiful images, which is called photometry, measuring brightness and position. This one is all about spectroscopy.
Right, so spectroscopy breaks down the starlight into its component wavelengths, like a fingerprint. What can that fingerprint tell us?
It tells us so much more. We can learn a star's chemical composition, its temperature, how fast it's moving toward or away from us, and even how quickly it's spinning. By gathering spectra for about 500,000 stars, this survey will create a detailed 3D map of the cloud's chemistry and motion.
And that helps us understand how they're interacting with our Milky Way, right? I've read about the Magellanic Stream, that huge river of gas being pulled from the clouds by our galaxy's gravity.
Precisely. This data, led by Dr. Laura Cullinane's group, will give us the missing link to model that interaction accurately. It will help us piece together the history of this cosmic dance and predict the ultimate fate of these two small galaxies.
So this isn't just about taking a picture, it's about conducting a census, a cosmic demographic survey. Are we looking at a timeline of years or decades before we can start drawing major conclusions from this data?
The survey itself runs for 5 years, but initial data releases will likely happen along the way. The full impact will unfold over the next decade as theorists use this incredibly rich data set to refine their models of galaxy formation and evolution. It's a foundational project.
From a cosmic dance to a cosmic U-turn, NASA's Parker Solar Probe has captured some incredible footage from its journey to touch the sun.
This is genuinely surprising. During its closest approach, the probe observed a coronal mass ejection, or CME. This is a massive eruption of solar material and magnetic fields from the sun.
And we usually think of CMEs as a one-way street, blasting out into space. If they're aimed at Earth, they can cause geomagnetic storms and the aurora.
That's the conventional picture, but Parker's images clearly show that not all the material escapes. A significant portion actually slows down, reverses course, and falls back toward the sun in these elongated blobs, which scientists are calling inflows.
So the sun is recycling its own magnetic fields. What does that mean for us? Does this change how we predict space weather?
It could. Understanding this recycling process gives us a more complete model of the sun's magnetic activity. Better models mean better forecasts, which is vital for protecting our satellites, power grids, and astronauts from the most intense solar storms. This is the first time we've seen it so clearly, and it's a huge new piece of the solar puzzle.
Okay, from solar physics to lunar politics. Anna, there's a new space race underway, but it's not about planting flags. It's about mining the moon.
That's right. The ambition has moved from exploration to exploitation. We have nations and a growing number of private companies like Interloon and Astrobotic actively developing technologies to extract lunar resources.
And the resources they're after are incredibly valuable for future space travel. You have water ice, which can be turned into rocket fuel, and helium-3 for potential fusion reactors.
The potential is enormous. The moon could become a critical staging post for the rest of the solar system. But this gold rush mentality is raising serious concerns. We're talking about the risk of environmental damage to a pristine world and the potential for geopolitical conflict over the most resource-rich areas.
And we don't really have any rules for this, do we? The Outer Space Treaty of 1967 feels completely outdated.
It's woefully insufficient. It says no nation can own the moon, but it's silent on whether a private company can own the resources it extracts. It's a huge legal vacuum. International bodies are trying to hash out new agreements, like the Artemis Accords, but there's no global consensus yet.
And that lack of consensus is the real danger. Without clear, internationally agreed upon rules, you risk a first-come, first-served situation that could lead to disputes and even sabotage. Establishing a framework for peaceful, sustainable resource use is as critical as developing the technology to get there.
Let's wish the policymakers well then.
Indeed, we're essentially heading into a Wild West scenario on the moon. This is a story we will definitely be following closely.
Let's turn our gaze now to a different kind of cosmic event on the horizon. There's a star system called V Sagittae that astronomers are watching very, very closely.
Right, this is a future headliner. So V Sagittae is a binary system, two stars orbiting each other. What makes this pair so special?
It's what they call a cataclysmic variable. One star is a white dwarf, the incredibly dense, collapsed core of a dead star. It's pulling in a stream of gas from its larger companion star, and it's doing so at an unprecedented, accelerating rate.
And when that stolen gas builds up on the surface of the super-dense white dwarf, boom.
Boom is right. The immense pressure and temperature will ignite a runaway thermonuclear reaction, a nova. Astronomers predict this will happen in the coming years, and when it does, the system will brighten so dramatically, it will likely be one of the brightest stars in our night sky, easily visible to the naked eye.
That's incredible, but that's not even the grand finale, is it?
Not at all. This process is causing the two stars to spiral closer and closer together. Eventually, they will collide and merge, triggering a full-blown supernova. The resulting explosion will be so mind-bogglingly bright, it might even be visible during the daytime. An amazing, if violent, astronomical event in the making.
Do we have a more precise prediction than in the coming years? Is this something we might see in our lifetimes?
The models, based on decades of observation of its accelerating orbital decay, point to a date around 2083, plus or minus a decade. So yes, it's very likely to happen within the lifetime of many people listening today. It's a rare chance to watch a celestial forecast come true.
For our final story, we're going from a system far away to the one right next door. We're talking about Proxima Centauri and its famous exoplanet Proxima B.
That's right. Proxima B is our nearest exoplanet neighbor, which makes it a tantalizing target. But studying it is one of the greatest technical challenges in astronomy. The planet is completely lost in the glare of its host star.
How bad is the glare?
The star, Proxima Centauri, is about 10 million times brighter than the light reflected by the planet. It's like trying to see a speck of dust on a floodlight from a mile away. But a new instrument called Ristretto is being built to do just that.
Okay, so how does Ristretto pull off this magic trick?
It's a combination of technologies. It's a spectrograph that will be installed on the Very Large Telescope in Chile. First, it uses a coronagraph, essentially a tiny, precise mask, to physically block the light from the star. Then, it uses a system of extreme adaptive optics with deformable mirrors to cancel out the blurring effect of Earth's atmosphere.
And once the star's light is suppressed, what's the ultimate goal?
The goal is to collect the faint light that has passed through or been reflected by the planet's atmosphere. By analyzing that light, Ristretto can search for the chemical fingerprints of gases like oxygen, methane, or water vapor, potential biosignatures. It's one of our best chances yet to find out if the closest world beyond our solar system has an atmosphere, and perhaps one that could support life.
And that's a wrap on today's top stories. From new frontiers in human spaceflight to the cutting edge of exoplanet research, the universe never fails to amaze.
It certainly doesn't. Thanks for tuning in to Astronomy Daily. Join us next time as we continue to explore the final frontier.
Until then, keep looking up.